Overtone music, a guide to harmonic fantasy number 7. The fact that a collection of harmonically related frequencies is perceived as a single tone with a distinct timbre is a rich source for musical invention. Most of our ideas about timbre come from musical instruments, which produce a very limited range of timbral possibilities. Since most people are familiar with musical instruments, I will concentrate instead on how harmonic spectra can be structured in electroacoustic music. In this presentation, I will reprise some of the points I have made in other lectures and articles, but I will also introduce a few newer ideas. All of the examples are taken from my composition Harmonic Fantasy number 7. I recommend that you pause the video and re-listen to some of the examples to make sure that you can recognize the properties that are being described. You may also want to leave figure 3 open as you listen to the composition. Spectra. Most sounds that we hear in music are not the single tones that we hear as the pitches, but instead consist of many different tones that merge into a single entity. Those tones constitute the spectrum of the sound, which is perceived as the tone quality or timbre. We can't speak of structuring them in instrumental or vocal music. Electroacoustic music is the first music that allows such a possibility. Musical harmony books usually illustrate the overtone series in a chart like figure 1, which shows the closest pitches to the first 16 partials of C2. In order to clarify the extent to which these are out of tune, I will use the octave point pitch class system, or 8VE point PC method of notating pitches, which is used in C sound and other synthesis programs. The pitch of middle C is near the frequency of 2 to the 8th, or 256 Hz, and the frequencies of the tempered scale can be generated by raising 2 to the power of the octave plus n divided by 12, where n is the semitone above C that you want. The result is then multiplied by 1.02199749, which raises the A above middle C to 440 Hz, which is the international standard. Some European countries use a slightly higher frequency of 444 Hz. In 8VE point PC, the pitch of middle C is 8.00, and each successive semitone is raised by 0.01. A440 would thus be 8.09, C above middle C would be 9.00, and the value of 8.12 would also work. The lowest note on the piano would be 4.09, and the highest note 12.00. Fractions of semitones are also possible, such that 8.005 would denote a quarter tone between C and C sharp. The main difference between 8VE point PC and the usual notation is that the octaves are numbered 4 higher, but this has the advantage that it provides a notation for subsonic or supersonic frequencies. This notation also works for intervals, where 1.00 would represent an octave and 2.07 would mean 2 octaves in the fifth. Now we can get a pretty good idea of where the partials lie in relation to the tempered scale. Figure 2 shows the intervals above the fundamental where the first 32 harmonic partials lie. As you can see, octaves are perfectly in tune, and the perfect fifths, 3rd, 6th, 12th, and 24th partials, major seconds, 9th and 18th partials, and minor third, 19th partial, are 2%, 4%, and 2% apart from their equal tempered pitches. The major thirds, 5th, 10th, and 20th partials, are 14% flat. Minor 7th, 7th, 14th, and 28th partials, 31% flat. Major 7th, 15th, and 30th partials, 12% flat. And the minor 6th, 27th partial, 6% sharp. These are also close to 1/10 of a semitone of their tempered counterparts. The one that is most out of tune is the tritone, 6 semitones above the note, the 11th being a little more than halfway above the perfect fourth, 49% flat, and the 23rd partial being about 28% sharp. This is one of the reasons why this note was so out of tune with medieval instruments, and the interval was referred to as the devil in music. Partials above the 32nd certainly exist, but they are very close together, and their pitches cannot be perceived independently unless isolated from their immediate neighbors or amplified. Also, when we consider the timbres of musical instruments, very seldom are partials this high taken into account, although they exist, and sometimes they can go higher than human hearing, in which case other interesting things may happen. Two of the most important issues when dealing with overtones in music are hearing the individual overtones and the emergence of the fundamental. Both of these are mostly irrelevant when considering instrumental or vocal music. There is a technique of singing vocal harmonics which is used in Tibetan chant and in Stockhausen's piece Stimmung, and which has also been used in a few other contexts, such as David Hike's harmonic choir. Learning this technique requires several months of training, and singers are not usually taught this way, but it shows that singers can learn to sing harmonics and become aware of them in music. When discussing musical instruments, we learned that players are taught how to produce the pitch, which affirms that the fundamental is always present, but these facts are not always evident in electroacoustic music. Overtone melodies and harmonies. While they are out of tune with respect to equal temperament, the intervals of the overtone series can be used to make convincing melodies and harmonies in the right contexts, especially if we can avoid the partials that are most out of tune, the tritone, minor sixth, and perfect fourth. However, in some cases we can even accept these. The entire chromatic scale is available starting with the 16th partial, 4 octaves above the fundamental. In order to hear these melodies and harmonies distinctly, we need to use rather low tones because their harmonics lie in a comfortable region for our ears. Let us illustrate this with a few examples. Example 1 plays partials 16, 17, and 19 of the pitch 7.03, E flat below middle C, 4 times in a row. This states the melody of 013, and it is clearly audible and acceptable as fulfilling this purpose. Example 2 plays the same 3 tones as a harmony. They are faded in individually in the same rhythm as example 1, and we clearly hear this as the harmony. Example 3 plays the same harmony on the pitch 5.03, 2 octaves below the previous examples, but in this case the partials include the lower octave duplications of the 16th partial. The fundamental emerges after about 3 seconds and sustains throughout the tone. However, we hear the same harmony as in the previous example. The partial sequence is repeated 3 times. Example 4 plays the same partial sequence, but this time the partials are attacked individually. The pitch is 8.09, A above middle C. Again, this creates the impression of both a melody and a harmony. Example 5 plays a more complicated harmony 0368, the dominant 7th chord. Partials 16, 19, 22, and 26 state the harmony at the beginning, followed by 3 octave duplications 8, 11, and 13. I think we can hear this harmony, but the fundamental 6.07 G2 does not emerge. This example uses both a tritone and minor sixth, but we can still accept the harmony even though those partials are considerably out of tune. Example 6 plays an A-flat major triad, 5.08, A-flat Mon, with all the partials in the sequence 16, 20, 24, 10, 12, 4, 5, 6, 2, 3, 1, stated twice. This clearly has a very major triad quality to it, and the fundamental emerges after about 3 seconds. Example 7 plays an A minor triad, 5.09 A1, using the partials 16, 19, 21, 24, and the lower octave duplications of 16 and 24. While the minor triad is not as apparent as a major triad in the previous example, it clearly sounds very different from that tone. Example 8 plays the harmony 014 on 7.02 D3 in a similar manner to the previous two tones, using partials 16, 17, 20, and their lower octave duplications. The fundamental emerges a little bit later than with the previous tones. To reinforce the minor second, the 17th partial is stated 4 times in sequence. Example 9 plays an even more complicated harmony, 02358. The partial sequence starts 16, 18, 19, 21, 26, but then goes on to include almost all the overtones up to 26. The only ones missing are 24 and 25. This creates an impression that starts with this rather complicated harmony, but then goes on to create a complex timbre-changing sound. The first half of example 10 plays the harmony 0457 as individual harmonics, but then goes on to include a transposition of 0457, resulting in a complex timbre-changing sound. The fundamental emerges about halfway through the sound. Example 11 again states the harmony 0457, but then repeats the partials to reaffirm this is the only harmony present. The timbre still changes constantly. Example 12 plays the pentachord 02457 on an E-flat 1, 5.03, the first 5 notes of an E-flat major scale. The pattern is repeated, reinforcing this harmony. The fundamental doesn't emerge until about 5 seconds into the sound. The timbre constantly changes, but in a coherent, harmony-reinforcing manner. I hope that these examples demonstrate to you the power and effectiveness of overtone melodies and harmonies. Let me conclude with a guide to my composition, Harmonic Fantasy No. 7. This composition is in 14 sections, each lasting 36 seconds. The tempo is 80 beats per minute, and the total duration is 8 minutes and 33 seconds. The entire piece is based on overtone melodies and harmonies as the above examples have shown. Figure 3, the table shown below, is a summary of the materials in each section. In order to allow high overtones to dominate the surface of the piece, only notes below C above middle C spanning a 4-octave range are used. The overtone harmonies and melodies used all state the harmony of the immediate context, that is to say, the notes that appear in each measure. In figure 3 below, this is indicated by the letter H. The piece begins with all of the notes in octave 7 below middle C, playing only the overtones that support the harmony. In the first section, the lowest partial is 16, and in the second, the lowest is 8. The second section introduces the octave below the opening, and in the third section, the 3 lowest octaves are used. Fundamental frequencies of any of the notes do not emerge until the fourth section. In the fourth section, the partials go down to the fundamental, allowing fundamental frequencies to emerge. However, the overtones still just support the individual harmonies. In the opening 5 sections, only tones that fade the harmonics in and out are used. In the 6th section, individually attacked harmonics begin to appear. These 2 instruments, labeled F for fading and A for attacking, are the only ones used in the piece. In the 8th section, all harmonics of the tones are used, resulting in complex timbre changes. Nevertheless, the beginnings of all the tones employ just the partials that emphasize the harmony, so that we always hear that element as a prominent aspect of the sound. Starting in the 9th section, the attacking partials are doubled in speed, and in the 10th section, which is the climax of the piece, the fading instrument returns. From this point on, only partials that emphasize the harmony are used. In Figure 3, the octaves are designated according to the octave point pitch class system, 8 equals middle C. I hope that this demonstrates some of the power and possibilities of overtone music. The composition may be heard on my SoundCloud page at the reference shown on the screen.